All right, we're at the top of the next page. We said that anytime a function has a local minimum or a local maximum at an interior point, if the derivative is defined there, then the derivative there must be 0. There will be a horizontal tangent. So this is a big deal. It saves us a lot of work because unless we already had a way to make a graph and we could be promised that we had integer values or values that were easy to read off a graph, then we would have to check the output of a function at every possible input value in order to figure out where the minimums and the maximums were. This says you don't have to look everywhere. If you're looking for minimums and maximums, extrema, then you have to check at endpoints, and you have to check at critical points, so places where the first derivative is undefined, where the first derivative is equal to 0. So I see how I use that word, but you saw it on the video at the end there. So we have this definition. A critical value is a value of a function, an x value, at which the first derivative is undefined or at which the first derivative equals 0. So this should say f prime of x equals 0 or f prime of x is undefined, defined. Okay, so now let's start to practice. You might see this question on the AP test. They might give you a function and say, what are the critical values? They might say, how many critical values are there? So this is going to be our job. This is a release multiple choice question. I'm going to do it on the whiteboard. So I have a function f of x, and I want to find out for what values of x is f prime of x equal to 0. So my first job is to find f prime of x. Now, you know, in your free response notebook, if you see a problem that asks about critical points, first thing you're going to need to do is to find f prime of x. All right, so it's going to require the product rule. So the first times the derivative of the second plus the second times the derivative of the first. So that's x plus 2 to the fifth times the derivative of x minus 3 to the fourth. 4 comes to the front, multiplies x minus 3 to the new exponent of 3. And I need to multiply by the derivative of x minus 3, but the derivative of x minus 3 is 1. And then the second times the derivative of the first. So the tricky part to this problem is to know how to solve this equation. Oops, I'm going to set this equation, this function, f prime of x, equal to 0. So first here, I just took those constants and moved them to the front. And I want to find out for what values of x is this function equal to 0. All right, so this equation, I could multiply it all out. Please don't multiply it all out. What's important to notice is that this is polynomial. This is a bunch of factors, x, like binomials, getting multiplied and added to other products of other factors. So I could multiply this out and it would be some ginormous polynomial. But the way to solve polynomial equations is to factor. So that's what I want to notice here. This function has two terms getting added together. So what I want to do is I want to look in the first term and the second term, and I'm looking for what factors multiply together to make those terms. And I want to notice what factors are common to both terms. I'm going to be able to factor those out. So here, this first term is 4 times 5x plus 2 is multiplied together times 3x minus 3 is multiplied together. The second term is the number 5 multiplied by 4 copies of x minus 3 multiplied together and 4 copies of x plus 2 multiplied together. So what do those guys have in common? Well, I have, let's do this in red, x plus 2 to the fourth, and here I have x plus 2 to the fifth. I can't take all 5 of those ones. I can only take 4 because that's how many x plus 2 factors the second term has. This x minus 3, I've got 3 of them in this factor, in this term. I've got 4 of them here. I'm only going to be able to take 3 of them out. So I notice that both terms have x minus 3 to the third power and x plus 2 to the fourth power in common. I'm going to factor that out. So I brought the x plus 2 to the fourth and the x minus 3 cubed to the front. And inside, I'm going to collect together everything that was left over. So everything I didn't use up by factoring it out to the front. So for the first term, that's the 4 and the extra x plus 2. For the second term, that's the 5 and the extra x minus 3. So that's how I end up with this. Oops, that's not the pen. Here's the pen. This is the leftovers, and this is what we had in common for both of those guys. All right, so now how do you solve a polynomial equation? You factor it and use the zero product property. So I know if, let's see, I'm going to put multiplication dots in here so I can tell how many things are getting multiplied together. I could put a dot there and a dot there. I can't put a dot anywhere in here, so this itself is going to be one separate factor, which could end up being equal to 0. That's the zero product property. So I'm going to have to simplify inside those parentheses. So here's my next step. Inside those parentheses, I'm going to distribute that 4 times the x plus 2. I'm going to distribute the 5 with the x minus 3. You can see what I have here. I'm going to collect like terms, and here's what I'll have. Okay, so 9x minus 7. So now this is 3, well, it's really 8 factors multiplied together, but it's x plus 2 times x plus 2 times x plus 2 times x plus 2. I'm only going to get one solution from that factor. So if these 3 things are multiplying together to make 0, then one of those things must have equaled 0. I'm going to write 3 separate equations. So x plus 2 equals 0, x minus 3 equals 0, 9x minus 7 equals 0, and I get 3 solutions, -2, +3, and 7/9. So as our original question was, how many critical values does this function have? Well, there are 3 solutions to f prime of x equals 0. This function has 3 critical values.